In this question, we are going to use the Maclaurin series expansion for 1 plus x to the power k, what we derived in the previous question, to find the Maclaurin series for this function. Okay, so this function here, f of x, which is equals to 1 over 1 minus x squared, can be written as 1 minus x squared to power negative 1. All right. Now, we know that 1 plus x to power k, this bit here, from the previous video, this is equal to the sum from n is equals to 0 to infinity of k into k minus 1 up to k minus n plus 1. This is where we stop, over n factorial x to the power n. So what we need to do right now is to try and make connections between these guys here. All right. So if you look at now I have to take that off. Now, if you look at these two functions, if you look at this and what we have here, all right, if you look at this and this, there's a connection between them. All right, we can see that k is equals to negative 1. So we can say that k is equals to negative 1. And then you can see that x here will be replaced by this. All right, x will be replaced by that. So what I mean is, for 1 minus x squared to the power negative 1, k is equals to negative 1. And we shall replace x with negative x squared. All right. So what's going to happen is, so 1 minus x squared to the power negative 1 will be equal to the sum from n is equals to 0 to infinity. Now we're replacing k with negative 1, so that will be negative 1, negative 2, negative 3, all the way up to, now this will be negative 1 minus n plus 1. And this will be, we replace x with the negative x squared. All right, negative x squared to power n. All this over n factorial. So let's simplify this and see what happens. So what we'll end up with is the sum from n is equals to 0 to infinity. And what we can do here is this, let me just write what it is before I simplify, one thing at a time. So negative 2, negative 3, all the way up to negative n. And this will be, we can split this up, negative 1 to the power n, x squared to the power 2n, or just x to the power 2n. All right, so this will be, I can actually just write that x squared to the power n as well, one thing at a time. All right, n factorial. All right, and then let's now simplify this. Sum from n is equals to 0 to infinity. Now here I can factor out from these guys here, all these guys here, all right, up to there. I can factor out negative 1. So I'll have negative 1 to the power n. And then I have 1, 2, 3, all the way up to n. Remember, I still have negative 1 to the power n, and this will be x to the power 2n, over n factorial. And now I can, now if you look at this, this guy and this guy will basically give me negative 1 to power 2n. I can still write it here, one thing at a time. N is equals to 0 to infinity. So negative 1 to power 2n. But now, I'm not sure if you can see this. All these guys here, this, oops, let me use a different one. This guys here, all right, all these guys here will be equal to n factorial, all right? So that will be n factorial. If you guys can notice that. So this will be n factorial. And then we have x to power 2n over n factorial. Now obviously these factorial guys are going to cancel. So what I'll end up with is a negative 1 to power 2n will just be 1. So my series will be equal to the sum from n is equals to 0 to infinity of x to power 2n. Okay, now to find the interval of convergence, replace x with negative x squared in the original interval of 1 plus x to power k. So what I mean by that is I'll just write what I've said, so that to find the interval of convergence, replace x with negative x squared in the original interval of convergence of 1 plus x to power k. So the original interval of convergence of 1 plus x to power k in the previous video, that original interval of convergence was between negative 1 and 1, all right? So what you're going to do is to replace this. We are going to replace this, all right, with negative x squared. So you're going to replace that with that. Okay, so what you're going to end up with is this. If we replace that, just need more space to work out. If we replace that, what we shall end up with is negative x squared is less than 1. You can write this absolute value as take the square out, so this can be written as absolute value of x squared is less than 1. Right, I explained that in one of my previous videos. And therefore, just take the square root of 1. So which means this implies that absolute value of x is less than 1, because the square root of 1 is just 1. All right.